In this lesson, we shall look at graphs and functions. Right, the graphs of f of x equals 2 over x plus 1 plus 4 in parabola G are drawn below. C, the turning point of G lies on the horizontal asymptote of f. The graph of G passes through the origin. B has the coordinates k and 14/3 is a point on f such that BC is parallel to the y-axis. Write down the domain of f. Okay, this is good news for us. And we want to write down the domain of f. Now, we need to recognize the fact that f is what we call the rectangular hyperbola. As a consequence, the rectangular hyperbola, which is this one here, is basically undefined at a point where x equals -1. So in other words, the domain has to be x, which is an element of all real numbers, such that x itself is not equal to -1. And this is the domain of the function f, whose equation is that one up there. Okay, so we have written down the domain of the function f, which is the set of all x values for which the function f itself is defined. It is therefore defined when x is an element of all real numbers except x equal to -1. In other words, x is not equal to -1. Next question is, want to determine the x-intercept of f. Let us find the x-intercept of f. Right, so now to find the x-intercept, so we're doing 5.2 right now and want to find the x-intercept of f. What we do is we let y be equal to 0. And when y is 0 in the function f, you will then have 2 over x plus 1 plus 4 equals 0, which is 2 over x plus 1 equals -4. You cross multiply and you get 2 equals -4x minus 4, which means 6 is -4x. And you divide through by 4, which is -3 over 2 equals x. So x therefore is -3 over 2. So, and as a consequence, it means therefore the x-intercept has the coordinates -3 over 2 and y becomes 0. Okay, so in other words, take a look at that one there. It is most importantly the x-intercept of the function f there. Okay, so think about it and ensure that you understand it. Simultaneously, this answer can be written differently. So the x-intercept is -3 over 2. And if the x-intercept is -3 over 2, it can also be written as what? Right, it can also be written as -1, remainder 1 out of 2, like that. And if it can be written this way, or so that this one can either be this or -1 and a half with 0. So in other words, 2 goes how many times into 3? It goes once, remainder 1 out of 2. And this is the x-intercept of f. Next, we have 5.3. Calculate the value of k. Right, k is here, but also k is clearly written here. It is the x-coordinate of the point B. Right, and obviously now we are doing 5.3. Right, so to do 5.3, there are a couple of things we need to take into account. And what do we actually therefore take into account? We're taking into account the fact that the point B has the coordinates k and 14/3. It lies on the function f, right? And the function f is has the equation f of x, which equals 2 out of x plus 1 plus 4, giving us x and y, so that y is 14 out of 3, which equals 2 over the x is k, right, plus 1 plus 4, like so. Upon careful examination, we have 2 over k plus 1. Right, so we have 2 over k plus 1, like so. And this equals, okay? So you transpose the terms, and we have 14/3 minus 4, and this is actually 2 over k plus 1. What is 14/3 minus that? 14/3 minus that is 2 over 3. We cross-multiply this, and if you cross-multiply this point, what are we able to achieve out of this? Right, so we have 3 times 2, giving us a 6 equals 2 times k, which is 2k plus k, or rather plus 2. And as a consequence, what do we have? We have 6 minus 2, which is a 4, equals 2k divided by 2, which means 2 is equal to k. Want to find the value of k, and it's clear, therefore, that the value of k is k equals 2. Right, now we continue to analyze these, but very, very carefully, and we look at what we need to get. Right, and so we need to therefore now continue and answer the next question. So we move on to 5.4, and we need to write down the coordinates of C. Let us check that one. Right, so to deal with 5.4 and to find the coordinates of C, and according to this information here, C is the turning point of G. Right, if C is the turning point of G, and also you are told that C, the turning point of G, lies on the horizontal asymptote of F. The horizontal asymptote has the equation y equals 4 when the vertical asymptote has x equal to -1. And you are able to decide on this and determine the actual values of x and the value of x and the value of y, which are the coordinates of the point C. Right, now, very important, but we are told that B is a point on F such that BC is parallel to the y-axis. So if BC is parallel to the y-axis, can you imagine that it goes straight down here, touching at the point at x. So our x here is the value of k. So x is 2, which is indeed the value of k there that we got previously. Okay. Now, with this then mentioned, we are able to state the coordinates of the point C. In other words, C will have the x coordinate. The x coordinate will clearly be 2, but the y coordinate is clearly a 4. So that the coordinates of C is 2 and 4. 2 and 4. 2 and 4 like that. Okay. And this is the answer. This is the answer. Okay, so y'all found the coordinates. Found the coordinates of C. Determine the equation of G in that form. Right, so now I want to find the equation of G, which is the parabola, 5.5. Now let us look at 5.5. To solve 5.5, we need to find clearly the equation of G. And what is G? G is the parabola, right? And what is the, so it must be in this form. So in other words, you have that y equals a, open bracket, right? X plus p squared plus q. Now, a couple of things, therefore, are very important. You understand that the parabola has the turning point C. It has the turning point C, and C has the coordinates 2 and 4. So this one gives a P and this gives a Q, so that we're able to say it is AX. Right, so it is X minus 2 squared plus 4, just like so. Moreover, this parabola will need an extra point, and it passes through the origin. So in other words, you need to write that it passes through the origin 0 and 0, giving x and y. And as a consequence, then you have a y, which is 0, the x, which is 0, plus 4, which is 0, equals 4a plus 4. 4a, which is minus 4. You divide through by 4, you get a minus 1. Okay, so that's what we have here. After having obtained a minus 1, the conclusion, therefore, is that our y is equal to, what is our a? It is minus into x minus 2 squared plus 4. Like this. So yeah, this is the answer. It is minus, open bracket, x minus 2 squared plus 4. Just like that, as written here. And obviously, we're to determine the equation of G in that form. In other words, the equation of G in the required form is therefore y equals minus, open bracket, x minus 2 squared plus 4. Like this. Next thing is we need to do 5.6. Let us do 5.6. Right, to do 5.6, there are a couple of things that we need to consider to answer the question 5.6. For 5.6, we need to deal with the f of g of x, which is less or equal to 0. So there are two instances in terms of signs, so we need to study the signs. So now to study the signs, you can have a positive over a negative sign, and the result becomes a negative sign. A negative sign can be viewed as less or equal to 0. Simultaneously, if this is not the case, you can have a negative at the top, a positive at the bottom, and the result is the negative, which is less or equal to 0. Okay, let's look at these, but pay particular attention to the kind of detail that is wanted. What do we do with this stuff here? We solve this with utmost caution. And we're going to study this and consider the fact that we need to also study the intercept to the axis. Okay, we found out that the x-intercept here of f is minus 3 out of 2. Okay, we determined that earlier on. Okay, and we have that in mind. This one here, my friends, what is this? 2, like this. 2, 4. Okay, this becomes 4 automatically because you see, this parabola has something we call the axis of symmetry. Right, it has something called the axis of symmetry, and because of the axis of symmetry, we're able to determine the x-intercepts. If you just know only one x-intercept, you can determine the other one. Right, so now let us, we're saying the axis of symmetry. Okay, axis of symmetry here, for instance, is x equals 2. So if it is 2 units here, it's also 2 units on the other side. So that this is 4 and 0. This one is going to be 0 and 0. Okay. What do we then need here? If ever we need to determine the values of x for which this is less or equal to 0, we need to solve this very carefully and think. We need to look for parts where, okay, let us do it like this and say the function f is positive. Let us use some signs here. Is positive all the way, and it is negative here. Just above the graph, we can just use, okay, when it's below the x-axis, it's also negative, and this is positive. Positive, 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 and this is negative. And then here, this one is positive all the way. Okay. Now, with this mentioned, what do we do with this? We continue to solve for x. And so to solve for x, we need to consider different parts of this graph. And now I want to perform an extension of this. So we need to know that this graph, the hyperbola, is restricted by the asymptote, but the The parabola continues, and if it continues, this parabola is negative all the way. And as a consequence, we're able to read off the solutions, meaning in other words, the answer to 5.6 is as follows. Right. So now we're going to state the answer, and we're going to state it as follows. What do we say? We then say that we have the part where the functions have opposite signs. One is positive and the other part is negative. So it's positive here and it's negative there. That is clearly seen, for example, at this point. This one is positive and this one is negative. So we can see clearly when x, and right here, when x itself is actually less than or equal to minus 3 out of 2. Okay, because it is only when we progress we can divide the whole plane here like this through minus 3 over 2. And therefore you can see that one is positive and the other one is negative. So in other words, in particular, to be more specific, the hyperbola is positive and the parabola is negative. Right, so we have that the top is positive and the bottom is negative. Right, so we have less or equal to 0. Now, there are a couple of things that we need to continue analyzing this carefully. Now, at this point, they are both negative. We don't want that. They must be of opposite signs, right? So here they are both negative. Here you have one is positive and they're positive, positive, positive. And then here they are both, now one is positive and the other one is what? Is certainly negative. So where do we see the answer there? Right. So let us analyze also this part here. Look at this part here. This one is negative and that is positive. So that is also the case. And this is a very important observation. Let us write this one down. So we have this one or, right, because I said here they are both negative, negative, but this is negative and that is positive. So there's minus 1 less than x less than 0. Okay, so obviously we cannot allow x to be equal to minus 1. So this is excluded. It excludes the minus 1 point is actually excluded, and also 0 is excluded because of the division by g, and clearly g has an intercept at the origin there. Or, okay, let's see this part. One is positive and the other one is negative. So, and that is going to be when x is strictly bigger than 4. But yeah, it can't be equal to 4 because the function g, the parabola in the denominator, is going to be 0 there. Okay, so yeah, so you have these 3 pieces of information, and therefore these 3 pieces of information, they form the answer to 5.6. The next thing we're going to do is to answer the question about 5.7. 5.7 is this one, and that is what we are looking at the moment. Right, so to look at 5.7, let us reason together. First and foremost, we need to take note of the 2 functions f of x. What is the equation? It is actually 2 over x plus 1 plus 4. G of x equals minus, open bracket, x minus 2 squared plus 4. Okay, so these are the 2 equations of f and g respectively. Now let's look at what the examiner is doing here. The examiner decided to write the following. So I want to write this one in green color. So the examiner wrote 2 over x minus 5, which is equal to minus x minus 3. X minus 3 squared minus 5. So what do? We have 2 over, and then you'd have x. According to the original, you'd have x plus 1, And then now we're going to put a minus here. Right? Now look at the colors. Okay, I want to make it a bit colorful. And we have the original. The original has a +4. So now if you have the original, that is a +4. You therefore have to achieve a -5, and therefore you can only do that when you subtract a 9, because 4 minus 9 is a -5. Okay, let us continue with the green color. So this equals, right, looking at the original, want to compare with the original. So the original has a minus. So yeah, even this has a minus. Then you have the original as x minus 2, but there's a -1. All right. Squared. And then now here you would have the original has a +4. The original has a +4, but what do we do with the +4? We want to make it a -5, so you subtract a 9 like this. And so what is the meaning of all these here? What is the meaning of all these here? Right, so this means a couple of things, and we write down the answer to the question as follows. So we note that F and G, okay, let's start from the extreme a little bit. We're looking at the answer to 5.3. We note that F and G are shifted. Right. How are they shifted? This F and G, they are shifted 1 unit, right? But also they are shifted 9 units, 9 units downwards, 9 units downwards. F and G are shifted 1 unit, right, and 9 units downwards. Okay, because now we're subtracting -9, it means that it's 9 units downwards, and also it is 1 unit to the right for both graphs. So now use the graph to determine the number of the real roots. So we're interested in the real roots. Right. Now, the couple of things that we need to also mention here in our analysis, because we need to explain. We need to explain the answer to this. So we also have, as a consequence, this we call the relative. It implies a relative shift. Relative shift of both graphs. So let's just write a bit more in detail here. We can write relative shift, but yeah, let's write a little bit more. So writing a little bit more, we can say, therefore, right, therefore, the shift of both graphs took place right. So let's write that clearly. So the shift of both graphs took place, right, relative to each other. The shift of both graphs took place relative to each other. Okay, so to each other. Okay, now, next point. Right, so, but most importantly now, if ever anything happens and we're able to see that these graphs are going to shift. If this graph, for instance, is at the origin and it shifts by 1 unit and it sits here, and this one is at 4, it shifts by 1 unit and it's at 5, and you have something like this. And then the graph further moves downwards by exactly 9 units, so that at this point, because you're able to see that the coordinates were 2 and 4, and therefore, if it goes down by 9 units, it's going to be, for instance, this parabola, it's going to be having a -5 there. Okay, as it's the coordinate of the turning point, something of this nature. But the graph will still continue in this direction. Okay, obviously the drawing is not to scale. And also this one is going to also, because it is at -1 here, but it's going to shift by 1 unit. So obviously this one is going to be at -3/2. It's going to shift by 1 unit, and it shift by 1 unit. It's going to be at -1/2. Right, so -1/2, and it still does this. Okay, it still does this. And as it still does this, there are a couple of things that remain very important. And it is the fact that there will still these graphs, because this one is going to have its asymptote as the y-axis, so they will still intersect in the third quadrant. So we need to mention that part. So this means, therefore, you have therefore now you determine the number of real roots. So therefore you have 1 point of intersection. 1 point of intersection in the third quadrant. Right, so these graphs, okay, here they do not intersect, but if they both move down, these two pieces, the parabola and the hyperbola, move downwards, they will not intersect on this side, but we agree that they were intersecting. If this one is continued like that, they were intersecting here. And then now, if even these graphs continue to be moved further down by 9 units after having even been moved to the after having been moved to the right by 1 unit and 9 units downwards, they will still intersect, because this graph is going to the hyperbola, it's going to have its vertical asymptote as the y-axis, which is x equals 0. So they will actually therefore still intersect. If this is the graph, the parabola that has been moved to the right by 1 unit and 9 units downwards, they will still intersect in the third quadrant. Okay, so 1 point of intersection in the third quadrant. Okay, what is the final conclusion then? So now, 1 point of intersection in the third quadrant. So 1 point of intersection in the third quadrant allows us to make the following conclusion, and write it here, and say that because use the graphs determine the number of real roots, so there is one real root. One real root. Right, so there is one, because there is 1 point of intersection in the third quadrant, there is 1 real root. Right, so we have 1 real root. 1 real root. Okay, so let's say that 1 real root there. Right, so we have 1 real root. So yeah, just take note of that. Because we have 1 real root, we've answered the question. We've answered the question. Once again, try to understand the shifts. So there is a horizontal shift by 1 unit to the right because of the -1. It means minus, if you subtract 1 from x, it means the graph is shifted by 1 unit to the right and then 9 units downwards, so that we have 1 point of intersection in the third quadrant. Okay, so that is what we have here. All right, and this is the answer. And we're excited and we'll solve this problem. Thanks everybody for your time and attention. And the answer to 5.7 that said use the graphs of f and g to determine the number of real roots. There's one real root. And this is everything written here is about the answer to 5.7. It's about the answer to 5.7. F and G are shifted 1 unit to the right and 9 units downwards, etc., etc. Okay, so and obviously now if you need to use the graphs to determine the number of real roots of these, you have one real root. All right, we're done. Thanks everyone for your time and attention, and goodbye to you. Goodbye to you.